building a JavaScript testing framework. Welcome back to this series about JavaScript infrastructure. This time it's going to be completely different. So there is an article on the website that you can follow to build a JavaScript test framework. So we're actually going to have code in there. The video today is going to be me live coding and building a testing framework that's a little bit similar to Jest. And then there's a podcast version which is also slightly different. So this time, if you want to have the whole experience, you have to actually watch, listen, and read all of it. But depending on which medium you like, you can choose the one that works best for you. So if we're just to give a quick intro, this series is about JavaScript infrastructure, and previously we talked about dependency management. There was a post with some ideas about how to change how we're doing JavaScript infrastructure, and I thought, even though this is quite different from what we've done before, I think it's quite interesting to kind of learn by doing, to figure out the basics of like JavaScript infrastructure. And like a testing framework is something that's like pretty fun to just put together in about an hour. I have the end result in front of me, but I'm gonna start coding it from scratch, and it shouldn't be more than like 100 lines of code or so. So we'll get through, go through that, and then see where we'll end up. And for me, the thing is that in the early 2000s, I was a teenager and I was building like web apps and browser games, and I built most of them from scratch with PHP and JavaScript. And one reason for building these things from scratch was that I didn't want to use any framework or library that I didn't understand. And the other reason was that things that I didn't understand felt like magic. So, I've since resigned to the fact that I cannot understand everything, but I spend a lot of time understanding two systems deeply. One is testing frameworks, and the other one is JavaScript bundlers. So next to compilers and type checkers, they are among the fundamental tools that make front-end developers effective. And at the same time, people rarely have the time to figure out how those tools work. And so this video is an approachable guide to understand testing frameworks. And in the end, we'll have a toy testing framework, and you'll be able to understand the fundamental concepts behind a test runner. And one of the cool things is that if you look at Jest, you'll notice it consists of like 50 different packages. So you look at this, it's like tons of different stuff in there. It's not just one package called Jest. It's actually composed of like these 50 packages. And for a basic testing framework that we're building, we'll leverage some of those packages. And by using Jest packages, we can both get an understanding of the architecture of a test framework, as well as learn about how we can use these packages for other purposes. If you'd like to learn more about how Jest is architected, I highly recommend checking out the Jest architecture video that is also on the same YouTube channel. So today we'll call our basic testing framework Best, and we'll break down the functionality of a framework into 4 steps that we'll work through today. Those are not all of them, there's a lot more to do, but I think those are the core things that will get us to something that works similarly to Jest. So 1, efficiently search for test files on a file system, run all the files in parallel, run all the tests in parallel, use an assertion framework for writing tests and then report results back to the test runner, and then isolate tests from each other so they cannot affect each other. If you're going to follow along, you'll need node 14 or node 16. What do I have here? Node 16, and we're gonna make a best effort to use ES modules, but that's still breaking down a little bit. So I have in the blog post like a small list of commands that you can run to, create the project and then add a few test files so that we have something that we can work with. So let's just run this and then see what happens. So I have a terminal here. I'll bump up the size of this for our thing. All right, I'll just bump these things in, and that will create a folder called Best Test Framework. We're in here, and then it has a package.json, it has node modules, it has an index file, it has tests, and then a yarn log file. So let me open this in VS Code, which is what we're going to use today. I'll also blow up the font size here a little bit so that we can see a bit more. All right, cool. And then if you look at the package.json file, I added 2 packages, one called glob, one called jest-haste-map. We'll make use of those in a second. And then here there are like 6 test files. They all have like very simple assertions. And the important thing is that every odd number test will fail and every even number test will pass for now. So this is just what we have here. Cool. All right. So to get started in a blog post, the first thing that we're talking about is efficiently searching for test files on a file system. So let's get started with that. So in most cases, this will maybe look familiar too. So let's just look at all the JavaScript files in our system. Actually, yeah, let's just get the test files. We don't need anything else for now. All right, one thing that I would like to have, it's already, I have Prettier working here. Perfect. Let me see. All right, I have Prettier working here, so that should make things easier. And then we'll switch to the terminal whenever we can, and then we'll run it. Okay, so here you can see this is just a glob function that gets us all the JavaScript or all the test files in the project. Or in this case, all the node modules as well. And that works really fast. But the problem is that for a really large project, doing this every time you start up your test run is really slow. So we'll be using one of the packages from Jest, and I mentioned this already here in the package.json file. It's called jest-haste-map. So we're just gonna get rid of glob, just remove it. And then we'll make use of this. The reason why I want to use this package is this: it's great for like a use case of a test framework, but it's even better for something like a bundler, which is going to be the next episode. And the cool thing about Haste, the naming is a bit of a legacy thing from like Facebook times, but the cool thing about it is that there's a tool called Watchman, also created by Facebook. You can install it, and then Jest will use it. And the first time you run Jest, it will ask it, give me a list of all the files in this project. And if you have a really large project, it might be, like 100,000 files. It'll be really fast at giving you that list, faster than any other option like glob or like using the find command or any of those. But the cool thing is that jest-haste-map will build a cache of those files, and then the next time you start up Jest, it will ask Watchman, hey, what has changed since on the file system since the last time it was invoked? And then Watchman will be like, oh, okay, here's 100,000 files, but you only need to look at these three because this one was deleted, this one was added, and this one was changed. So the cool thing about this is it's incremental. So this will stay fast no matter how big your project will be. And I know just running a glob is like very simple and fast, but it will break down in the future, and like just using haste is going to be a lot faster. So we'll just do this new haste. The problem is I'm using MJS files, but the way Jest27 exports things together with MJS doesn't really work super well. If you're using like TypeScript or Babel to compile your JavaScript files, you can just invoke it like this. This is a bit unfortunate, so we have to do new haste.default because it cannot like map this back to the haste object. So that's just what we're gonna have to do. And then so one thing is that we need to like figure out a root, and like this is there's no dir name thing in MJS files, so we're gonna have to do something a bit more funky here. So we're gonna get the dir name from path. It's like a function on the path module, and then there is a module file URL to path that I learned about recently from the URL package, and then we're gonna get the root of our project, which is in this case just our folder. This one is file URL to path import.meta.url. So that's the same as like dir name. Let's add a comment. This is dir name MJS file. All right. So and then we need to pass this root there to like haste-map. And then the other thing is there's a bit of funky stuff here. With the haste-map where we actually have to pass in the root twice, because the way it works is that usually in a big monorepo like Facebook has it, for example, you have a root directory where Watchman is watching, but then you might not want to watch all of the files. There might be like 10 million files in that repository. You might only want to look at like specific folders, so you can specify the root directory, and then you can specify subdirectories that are like just look at the JS folder and like the scripts folder or something, and not at anything else. We don't really need to use that, so we're just going to pass the root into both. another thing that's cool about the haste map, well, one is I talked about Watchman, and you can check that out. But if you don't use Watchman, the cool thing is it will just fall back to like using a crawler written in Node.js, or the find command even, which is also pretty fast. The cool thing is that it also does all of its work in parallel across different worker processes. So we're gonna actually get there's like a max workers command, yes, and we're gonna pass it the amount of CPU processors that we have on the system, so we can parallelize work efficiently. So not only does it get the list of files, it also analyzes the files and gets an understanding of the dependency graph of a project, which we'll see in the next episode. So please stick with me. There's like a legacy argument platforms we need to pass. We don't really need that. It's more of a thing for React Native. We need to tell it which JavaScript file extensions we want to look at. Sorry, not which JavaScript file extension, which extensions we want to look at. So in this case, just JS files. And then the next thing we care about is we have to give it a name for the caching. So we're gonna call it best testing framework. Okay, and then we need to build it. So the thing that we have to do is we need to do await haste-map.build, and then this gives us back some things. One of them is called hastefs. So let's do hastefs get all files and then see if what I wrote works. Yeah, it works. Perfect. So actually, the only difference to glob is that this gives us absolute file paths. Those are not stored in the cache because it might change and it makes the cache portable, but the hastefs thing like kind of concatenates these things together. So the great thing is we have all the files in the project. So even if we had a non-test file, it would give us that file, and that will come in really handy in the next episode. But the thing that we care about is we want to just like get the test files. So the great thing is this hastefs thing. The idea here is that this is like an in-memory file system. So we could also call it, memory file system. So we can do like file system operations like hastefs.exists, tests01 test.js, and then if we log that exists, it should tell us yes, it exists, and then if we make a typo, have a typo here, it doesn't exist. Okay, cool. And that happens now in memory, and obviously if you're building this in-memory file system, things can change on the file system in between operations that you're doing in your test framework. So the cool thing is that hastefs also has a watch mode, so that whenever a file changes, it can update the representation of the file system in memory. We're not using that now. There's a command called I think watch, and you can turn it on, and there you can subscribe to change events. We're not going to do that today, but the cool thing is that yes, you can call exists here, and that file might have been removed, and the memory file system might not have been updated, but jest-haste-map actually takes care of all of those things for you. So what we want is we want to have all the test files. And so the hastefs also has match files with glob. Okay, and now we can give it this thing that's gonna say, give me all the JS test files. And then I think that's a set. So let's just log this. Perfect. So this is a set, and this gives us only the test files. So here's the thing, what we could do is give us only the first test. Okay, it works. Perfect. So now we get all the test files. And then the next thing we need is let's read the test files. So we'll get the fs module, and then for each test file, we'll do, wait, is it for await? And then we'll do code promises.read file, test file, udf8, and then we'll log the code. So in this case, we should have, oh well, these are all, that's a mistake, we have to await this. All right, cool. So now we're printing all the test code from our entire project. That obviously doesn't run any tests, but it's a good way to verify that things are going well. We can also make sure that these things actually line up. Perfect, so this is actually the test number 6. It expects 6 to be 6. Perfect, this actually is correct. So we have everything that we need to, in the first step, we can kind of like efficiently like find all of the tests. So now the way Jest works is it runs tests in parallel, but Node is single threaded. And the thing that we want to figure out is how can we actually start multiple processes or threads. They're, for our purposes, effectively the same thing, and we're actually going to abstract away from that. But you know, we could just like run our code here and then serially run all of the tests. Even though, you know, there's async programming here, only one instruction at a time will be executed. But if we have a lot of tests, we want to make use of all of the available resources on the machine that we have. One of the things that Jest unfortunately does not have, that I wish we added, and that actually would be fairly easy to add, given like how Jest is separated and how it works, is that instead of running Jest tests across different processes, we could actually run tests on different machines, different CPUs, right? Like, so let's just say you have like 10,000 tests, you cannot run them on a single machine efficiently. You could just run Jest and then it would actually spawn processes on different computers, on different VMs, and then run the tests there. It's the same concept, but unfortunately this is not something that's part of Jest. So the first thing we're going to do here now is we're going to add a package called jest-worker, and that package is useful for doing things in parallel. And even though Node.js now has threads, it's a little bit clunky to work with that, and jest-worker abstracts away from all of that. So we can just use jest-worker, and that's like pretty sweet. So let's start by creating a new file called worker.js. And then we'll take this, well, the thing is, one of the limitations is it doesn't work yet with ES modules, with MJS modules. So we'll use a JS file here. So we'll have to resort to requires because we're not gonna run any code. So the thing is that we're gonna have like a run test function. So we're gonna have an async function that's gonna be reading the code. Okay, and then let's just do the same thing as earlier. We'll just return, that's not necessary, we'll just return the code. So one thing we could do here now is we could just import the run test function from the worker file and then just do like, we have to await that. And that basically, oh, wrong command. I have to do. Okay, so this doesn't work. So still new to MJS files. Big fork to the ecosystem, not great. Okay, and require is not. All right, so this should work, right? Yeah, perfect. Okay, so this works. So we're just importing the worker and then running this run test function. Okay, the problem is that this is actually still single-threaded. We're not using the jest-worker package like we were talking about. So let's import worker from jest-worker, and then we'll also need the a module from, or a function from the path module to concatenate a path, because we'll need to refer to the worker module with an absolute path when we're creating the worker instance. So let's create a new worker, and that file is the worker.js in the root. So now we have a worker. And one thing we can do is that this doesn't use worker threads yet in Node.js, because when we added support for threads, it wasn't super stable. So there's a function called a flag called enable worker threads, and now it actually will use threads. If this is gone, if this is not there, then it will just use processes, which might not be ideal and might use more resources depending on which operating system you're on. But this is going to start a worker process. Let me just put this all to the top of a file. We can have join here. Okay. So now we have this worker function. And then one thing is also when we're done, we call this end method, because we have to like kind of shut down the threads or the processes. And then here we have to figure out how to run the test. So the cool thing is that it automatically figures out what are the things that are exported on this from this module and then puts it on that worker function. So we created this instance of jest-worker, and then we have this instance here in the worker variable, and that will have a run test method that then we can pass the test file in, and then it gives us a result. And the cool thing is that jest-worker abstracts it away. If you're using a different process, it will like marshal this data here, which is like a string, and pass it on to the other process and then receive back the result. So now we can run this and let's see what happens. It actually doesn't work because worker apparently is not a constructor. We might have to say nope. What's worker? Okay, so apparently this is just an export. Okay, something to figure out. All right, cool, perfect. Now things work, and now things are actually parallelized. Interestingly, everything here works. Oh yeah, no, now if you run this multiple times, you see how certain things are run in a different order every time. It seems to be fairly stable, but just earlier I got it to run, and oh yeah, now it's out of order. So here, for example, you have the third one is like comes back out of order. So the thing is that it spawns processes, or in this case worker threads, and then I know I'm talking about threads and processes as if they're the same. For our purposes, we're just abstracting away from them. I understand that they are different. So I'm sorry that I'm using the same word, different words to talk about. Sorry, the same word to talk about different things. So now we're running this, but then because it actually runs in parallel, we also run these things. They take different amounts of time to run, and then they will report results as soon as they're done. So we cannot rely on the order of processing the test files here anymore. They will just run and then execute and like be done and report the results as soon as they're done. So the cool thing is that we have this system now where we are fetching all the files and then running all these tests in parallel. We're not actually running the test yet, we're just reading the code that's in like those test files, but you know, it's a good start. So the thing is we'll need to actually get some results. So we can do something like test results from running the test, and then here we can like figure out what our test results look like. So here is, let's do test result. There is a success boolean. It will start out as false, and then there's no error message. There might be one if something fails, and then we'll actually return the test result here. Let's save that, and then, oops. And then we'll get some information here, and then we can handle this. Let's actually go back and actually write some test, write some code to execute the test. So the interesting thing is that we need to figure out a way to run this code, and this is all in a separate process. So one thing we could do, we could just eval that code and then see what happens. So now, it actually says expect is not defined. It will take down our entire test framework. So let's do something like this. We'll try to run it, and then if it fails, we'll say test result dot error message equals error dot message. And now it runs. We don't have any output here. Actually, also we need success is already false. Perfect. So here we can probably say test result dot success equals true. And then here, what we could do is, if there's an error message, it's not successful, we'll do console.log error message. Okay, expect is not defined. Okay, it tells us that for every test. Let's add some color here. Okay. And this is also where we can like add the iconic printing from Jest. So let's do something like this. The status is if it's successful, we'll do, I think it's like green.inverse or something. Otherwise, we'll do okay, let me save this, perfect. And then I think, yeah, the way it works is status plus the test file. Oh, oops. That's getting some color. Perfect, okay. The one thing is here that it actually shows the entire path to the test file. So let's make this relative by adding the relative function from the path module and then relativizing this. Oh. Perfect, okay. So this looks like Jest. I think we can add some indentation here for the error message. All right, so every test tells us that expect is not defined, and we're evaluating the code here. So this is basically an entire test framework. So if we didn't use expect here, what we could do is like, you know, just 1 equals 1 and run it, and then one of our tests will pass. Perfect. So the problem is that we just don't have anything that looks like expect. One of the cool things is that because we are running eval, we can do something like, we can just define it here. So we get the code, we eval, and then we can do const expect. So the way it works, let's just write, you have an assertion here, expect 1 to be 1. Okay. So how does that work? So we call this function expect, and then it returns an object with a to be function that we can invoke as well. Okay, so we get the received value. This is something that in Jest history is something that we had to discuss for a very long time. There were a lot of test frameworks out there that when a test would fail, it would say expected actual to match value or something. And the word actual was like, to me as a non-native speaker, a non-native English speaker, was super hard to wrap my head around, because does it mean the actual thing is the thing we care about, or the thing it should actually be, or that we want it to be? So we had this long debate, Aaron Abramov and me, about whether this should be the received value or whether we have a different word for it. So we expect the received value to be the expected value, and that was the kind of framing that we thought was, or the naming that we thought was like the most useful. So here we'll say we receive a value, and then we'll return a matcher called to-be, and that one gets the expected value, which then will check if they are the same. So if received equals expected equals, and then if it's not, if it doesn't match, we'll throw an error, and they will say expected as expected, oops, wrong parenthesis, but received. All right, and then we can add like maybe some way to highlight this. And this actually, the cool thing is because we're using eval, we have a full expect implementation here, at least with this like, well, I actually have a typo somewhere here because it's not printing properly. And yet another typo. Okay, perfect. Got confused confused there with my parentheses for a second. The cool thing is that because we're using eval, we can just define this variable here and it will just be part of each of our tests. So now let's run our test framework. Perfect. Now all of the even tests, they pass, all of the odd ones, they fail, as expected, because those are the tests that are intentionally failing. So we could fix up all of them, for example this one, and then run our test framework, and then tests will pass. Perfect. So the thing is that, you know, it's not very easy to add like all of these assertions. You know, there are these things like to be greater than, to be greater than, to contain, to string containing, I think. Yeah, something like that. So there's a lot of different matchers. It's a lot of work to add them. So one of the cool things is we can just pull that in using the expect package. So we yarn add expect, and then we just require it. And then the sweet thing is that we run tests, and then we actually get like really good error messages. So here we expect the receive to be expected with object is equality, and then we expected 6, received 5. So now we have actionable error messages that tell us something is wrong and how to fix it. And we have all the matchers that we want. So here we can do expect apple string containing pp. Where's our first test? Oh wait, this one is failing here already. Wait, string containing is not a thing? I need to figure out, well, let's do to contain, where is it? Okay, our first test is passing. All right, so I don't know the matcher API as well as I thought I did, but you have all the matchers from expect. One of the cool things if you're playing with this is you could add a matcher called expect a function to throw. If you're still writing your own matchers, your own expect library, if we go back to this, you could add one called to throw. How would that work? Expect a function to throw. Wait, this is not a function, that will be just empty. And then here what we would do is we would like add a try catch. And then we'll run the received function, and then we will it didn't throw. Okay, so now I added a to-throw matcher to our custom expect implementation where we're receiving this thing, which should be a function here. And then we call to-throw, and then when we call to-throw, we run that function, and if it throws, then we'll set this to true. And if it hasn't thrown, we'll throw an error. So let's see what happens when we run our first test. Again, this assertion needs to be updated. It didn't throw. Okay, so now it does throw, and our first test should pass, and it passes. Perfect. So the cool thing here is that we are expecting this function to throw, and if this function throws, the test will not fail. That's why I like this matcher so much, because it's kind of like this inversion of control where you kind of want everything to pass in your code, but then sometimes you want it to fail. And then how do you make a matcher around that fact that something is expected to fail? And the solution is so simple and elegant. You just, you know, wrap that function in a try-catch block, and if it throws, then you pass the test. All right, let's move back to our expect library. Perfect. So now we have our test framework with like pretty error messages. One of the things that we can add is that here when we can have something like called so right now we are exiting the process as if everything is like good and everything has passed. What is it like? Echo status. I'm using fish shell. It says 0, which means that this process executed correctly and there is no issue. But because it's a test framework, we might want to run this code on a continuous integration system. When a test fails, we actually want to exit with a non-zero status code. So one of the things we can do is we can check, has the test run failed? If one of them is not successful, we can set this flag to true. And then at the end, if it has failed, we'll print out we'll print out like a message that says your test run has failed. And then we'll set the exit code of our test framework to 1. So now when we run it, it will say the test run has failed. Please fix your failing test. And then when we print out the status, it says 1. So that means the process failed. Perfect. So we have that. Now let's go back to extend our testing framework a little bit. So if we create a new test, like a test framework has something like mocking. So if we create a new test, I got like a mock function here. This is something where, Jest has like this fn function. Let's just call it mock. And then we want to have this thing where it's like we expect this function not to have been called and we call it, we expect it to have been called. This is something that every test framework will come with. I'm not entirely sure if it's obvious. I haven't done this for the blog post, so I'm not entirely sure how to best implement it, but we could like give it a try. So this is completely live now. So we'll define a mock fn function. This can have like an implementation, I guess, but then here we'll have to return something. And the problem is now that it has to interoperate with the expect functionality. So this will be a mock function, okay. And this will probably not use arrow methods because we'll have like references to this, but like let's just do it like this. So we have a mock function that we return. When it's invoked, it will run this implementation, only if it's available. And then we have to add something like mock.calls. That's like a nested array, I think. And then here we'll do mock fn.calls.push. And we'll pass in an array. The question is whether the expect library works like that, if the to have been called match or works like that. But we can actually just try this and see what happens actually. So one of the things is that we're currently just running all the tests every time, but now that we're just focusing on this one thing, let's actually change our match files with glob function so that we can specify whether we want to run like a specific test or all of the tests. So let's make it so that when we pass an argument to our test, let me figure this glob out later. So something like this, we'll want to get all of the files that, okay, and then plug this in. Always keep using the wrong quotes. Plug this in, but then we also want it to match at the end, I think. Okay, so now we should be able to run mock test. Okay, cool. So we're running this code. Problem is, this is not working. Expect received not to have been called. Received value must be a mock or spy function. So I'm just gonna look into expect and then see how that works. There's a lot of stuff in here. Or is to have been called? Spy matchers here, okay. So let's see. Okay, there's a flag called is-mock function. So let's just see what happens if we add this to our mock. That's definitely legacy code that's like more than 10 years old, that's been there for a very long time. Okay, get mock name. Cannot read property calls of undefined. Oh boy, and we don't get a good... Oh, there's a count function on it. There's so much stuff in there. Oh, receive.mock. Okay, so it's .mock.calls and then count. I'm really curious now if this is gonna work out or if I'm just gonna give up. .mock. Cannot set property calls of undefined. Oh boy. Oh, I see. Of course. Oh, it works! Oh my god, this is amazing. So now we just figured out how to build a mocking library by reverse engineering the expect library with like a ton of custom stuff. So this is like, you know, this should be using a symbol, but it's like legacy code from like literally 10 years ago, or maybe 8 years ago, where we added this private field to say that this is a mock function. And there's like some legacy stuff. I think this calls.count, it might be from like some mocking library early on in web browsers, because like obviously this could just use like a length property, but this is working. It like expects the function not to have been called at first and then expects the function to have been called. As you can see, this is a bit cumbersome, and given that expect has support for like mocking libraries like this, we could like build this and like ship it and like put it on npm. It's not ideal. We'll go back to our previous trick. We'll add a library called jest-mock, and then we'll import it, call it jest-mock, and then let's run our test. And it passes, perfect. So this library is part of, let me just close this, part of Jest, and it provides an entire mocking solution that works together with expect. So now we have like pretty much all of the functionality that like a test has available inside of Jest. I think the only thing that is not gonna work definitely is snapshots, because that requires specific integration. That's something you could like check out. There's a package called jest-snapshot. So I recommend you look into that. So the next thing that I wanna look at is, in most test frameworks, we have something called describe. I have like an example here. I'm gonna create a new test, describe.test.js, and then I'm gonna paste an example here. We're gonna describe like a function, and then we're gonna have a function called it, and like inside of that we have assertions. So if we run this, it will fail because describe is not defined. But in most test frameworks, there's this solution to group tests together, and then to group like certain assertions together based on a specific topic. And that's like a really critical functionality for most test frameworks. So I'm just curious, what do you think would it take to build like describe and it? Let's just try to like build it. So the thing is that these take like a name and then like a function. Both describe and it work very similarly. So the thing is that now we need to like define describe, and then we need to define it and their functions, right? So we have a name and a function, they do something, and like a name and a function, and they do something. And now if we run our code, it'll probably pass. That is because, you know, describe exists, and it will just like call this function and then be done with the test. It doesn't actually execute anything. So ideally we'll just actually run the test. And so the interesting thing is the way it works is that we just collect these blocks, and then we need to run those functions at some point. So we have like something like describe fn's, and then we'll keep track of them. That's just like an array. And then we can push that in. So we say describe fn's.push name and function. And then at some point we need to like run it. And when we call it, we need to know which describe this is in right now. Okay, so we can do const current describe fn, and that's, oh wait, that's mutable because we're gonna change this. So when we run one of the describe functions, we can actually pass, put it into the it. Sorry, when we run a describe function, we can keep track of the it definitions. So we'll also push the name and the function in, and now we keep track of things, but we also need to run it somehow. So how do we do that? That's gonna take us a little bit of coding. Let me just run this. Cool. So first off, we can have a test name now. Okay. And then here, after we run, so okay, we're defining describe, we're defining it, and so we're keeping track of those describe functions. We're not actually running we're not invoking it anywhere because we're just calling describe. But if we were running the describe functions, we would also be collecting the it functions. So let's go through them. I think what we can do is we can destructure this here. Just go through all of the describe fn's, and then we say current describe fn is like a new array. We're just gonna reassign this, and then the test name, wait, test name is this, okay. And then, all right, we have, okay. And then we want to execute that function. And then we should have all of the it calls in this array, because we are executing the describe function, we're setting the current describe fn variable, and then that means when we call it, we'll push the name and the function of the it call into that array. I'm sorry if this is a bit hard to follow. It's a bit, I should have called this test. That would have made it much easier to like follow me, I think. But let's just see where we get to. So now, for const name fn of current describe fn, well, it name and it fn, okay. And now we'll run those, and then we'll actually run our test. So we can extend the test name plus it name. Let's add some spacing, maybe also, yeah, okay, that's good. And then we'll run the it fn, and I think that might work. Okay, one of them fails. That is because this example fails. Okay, let's run it, and it passes. Okay, so it's actually executing all of our code now. Cool, this works. So now we can actually, when it fails, we don't really know what's happening. So let's add the test name here. Perfect, second describe test doesn't work. Perfect, all right. So, and then that's pretty much it. I think describe and it works. Perfect, now we actually see what's failing. So if we do, that should work for everything. Okay, I guess we have the root here where we don't have describe blocks. Let's just keep using this for a moment. The problem is that this is like a lot of code and it's very confusing. So the cool thing is that there's a test runner called jest-circus, and that was created by Aaron Abramov a few years ago, and now with Jest 27, or I think with 27, yeah, it became the default in Jest, maybe in Jest 26, but this is like the new test runner that replaces Jasmine. So let's add that, and then we can get rid of all of that code again. And then we can simply import describe and it from jest-circus. The thing is that we also need to run our tests because as we saw earlier, we're just collecting the describe and the it blocks. So the way we can do it is we can do test results await run, and that runs all the things, and then we somehow need to like process these. So test results, let's just log them and then see what happens. We're probably not going to see them because it's run in another thread. Okay, things just pass because we're not running stuff. Yeah. All right, so we cannot log them. We can return them. I'll just give it away. Oh, actually, we'll just return them to the parent process and we can log them here. And then we'll see what we're getting from this. Oh wow, that's a lot of stuff. We get an array with objects inside, one for each describe block, I guess. And then it has like a bunch of stuff like errors and the status done. Okay, I guess if it has errors, then it means something failed. So what we can do is, in our worker, instead of setting the success to true, we say test results for every test result. If result.errors.length is 0, then that means it succeeded. All right, now it fails because it actually broke. One of the differences is that because describe and it, they are actually wrapping everything with try catch, so it won't hit this part anymore of our code, only if something actually like really breaks. So we can actually get rid of all of this again. So only if you throw like in the top of your test, like you throw here, it will bump into that try catch block that we added earlier. But now we actually need to analyze if an individual test failed. And the cool thing is that we don't want the test to stop running when it throws here. We want to run each block and then report failures per test. So that's why jest-circus works differently. And then I think that's pretty much it. All that we need to integrate like jest-circus. That's like pretty sweet again. I think we might need to do something differently in the main process. Yeah, okay, this is not great. Let's get rid of this. Okay, it's reporting the right thing, but I think we can actually add the names of each test and then have better error messages, I think. So let's do something like this. If it doesn't succeed, and if we have test results, and then we'll filter them for the failed ones. And then we will go through all of them. Oops, cannot see anything because of the hints. We'll log the name of the test. Okay, so we looked at this earlier. We have a test path here. It has this root describe block. That might be something internal. We can just skip that, and then we have these blocks. Okay, perfect. So we will do result.testpath.slice1 and then join it, and then add the error messages. All right, and then this one. Okay, so we won't have test results if the test crashes. And so if we have an error message, we'll log that. Okay. What happened? Oh, perfect. Okay, so now we actually get a stack trace about where things are failing. Perfect, and it says second describe test doesn't work. All right, that's our test framework. One of the things that's a bit weird here is that we're running jest-circus here, but we might have fewer processes than we have tests. So this run test function in one process will be run more often than once. We can actually maybe try that if we set the the workers. Does it have like a max? Let me check it out. Node modules, just worker. All this compiled code is kind of hard to follow. Does it have a max workers? Num workers, okay, that's a bit inconsistent. All right, so let's just control this and say num workers is 1. And now the problem is that jest-circus doesn't reset its state, and it will probably have multiple tests failing with the same thing. Yeah, you can see that here. You're running tests and like they all fail with the same error because it like kind of keeps collecting results, and we actually need to reset it. So there's a function called reset state, and then every time before we start running tests, we'll reset the state. And now only the tests will fail, only the failing tests will fail, and there's no state shared across tests. Okay. So we have about 100 lines of tests of code now. That's because of the white space. We're not going to add a lot more code here. I think it's about 100 lines, and it'll stay there. But one of the problems is that all the tests can still influence each other. So let me add something like array.prototype. Something that will break stuff. I guess none of our tests are very complex, but I guess maybe number.prototype.value of is a function that returns -1 for all of the tests. Let's go back to the num workers one. Let's see if that works. That actually doesn't work. Even though I'm using eval, it seems like there's one thing we could do. We can do const a. That should definitely work. If they all run in the same process, they should all fail the same. Alright, for some reason I cannot get this to fail the same way I did earlier. So maybe you just have to trust me on this. I guess one thing we can agree on is that just running eval in this process here is not ideal, and that means if we run multiple tests, they will all start conflicting with each other, and you might have this experience if you ever used a framework different from Jest, where you ran all the tests and they were just like affecting each other depending on which order they were run in. Unfortunately, I couldn't repro this right now, but you know, eval is not a great solution for running these things in the parent context. So one of the cool things is that Node has a feature called VM, and it allows you to create a new context. It's similar to iframes, so this is not a security model. Don't use it to run, you know, user code in your server or something. But for test framework, it works really well. The way it works is that we can create a context. So we do context, we pass it. Also, one of the things that, I guess this is a good way to figure it out. Okay, so for example, we call eval here, and then we have like, let's say, yeah, I guess fs is a good one. We pull in the fs module here, Or let's say we have like const secret is like my secret. And then we have the describe test that expects, what did I call this variable? Secret. Something like this. And then the describe test will probably fail. Okay. Normally you would expect this to say, oh, secret is not defined. But instead it fails with a secret does not match my secret. So the thing is, anything we define here is just automatically available in every single one of our tests. And that's not ideal. So that's, I guess, the point that I'm trying to make with like sandboxing. So how do we avoid that problem? And that's where the VM module comes in. So we can create a context and we'll pass it the things that we want it to be available in that context. And then we do vm.create context. And then instead of eval, we'll do vm.run in context. And we pass it the code and the context. And then we run it. And that works. Okay, and let me just see if secret is 1. So just adding this back, and now we run it. We look at the describe test and the secret is not defined. Perfect. So even though this is not a secure sandbox, you know, if there were actual secrets on your server, don't use this to like isolate things. You should like, you know, do completely different things, like use an actual VM or, you know, different process at least, but definitely not use the VM module for like security purposes. But for all intents and purposes here for test framework, we can create a VM context which is similar to an iframe, where we can run code in an isolated context where it doesn't have access to things outside of it. And a great thing here is that we create one new context for each test. And you know, we could also move this up and then intentionally run all of the code in the same context. You know, there might be reasons why we want to do that. For example, if you're trying to create like something that evaluates like code within like the same context, but shouldn't be the parent context. But for us, we just want to run it in like a separate context. So now I want to add a new test. And I think, yeah, I have like a code example here. That doesn't work right. All right. So let me add like, turn this test into something async. So the expect framework and jest-circus support async testing, you know, so you can wait for a test, you can have like async tests, you can have behaviors that take a certain amount of time. So let's just add like a sleep call here. So it will take 2 seconds to resolve this test. Oh. Wait, I still have this secret test, expect 1 to be 1. Here, okay, so now that we're using the VM module and it isolates everything, it says set timeout is not defined. So the way we would do that, we can pull in set timeout into the context, because that's a global, so it should be available. Now it takes 2 seconds to run our test. Perfect. That's cumbersome because Node has different things like buffer and like clear timeout and like all these kinds of things. You can probably guess what's coming now. We're going to add a module called jest-environment-node, which we can use to create a context that we run our code in. So this is not an actual Node.js runtime, but it emulates a Node.js runtime. So it adds like certain things. So if we open this here, you can check out what it's doing through compiled code. So it like creates a context just like we did, and it creates a global variable. It adds clear interval, buffer, array buffer. There's like all these kind of like small things, like it adds URLs, search params, text encoder, decoder, all these kind of things that are part of like various different versions of Node.js to make the VM context for jest tests feel like it's an actual Node.js environment. The cool thing is also that this is how the fake timers implementation works. So either you pass it the actual set timeout functions, or you hand it like a fake timers implementation where you're giving it set timeout functions that are like not the actual global object, the global set timeout object, but rather fake timers that are created from the fake timers implementation. So let's try that. So instead of the context here, we're gonna create an environment. And then I think it has something like test environment options. Perfect. Thank you, VS Code, for the auto completion. So we don't need this context anymore. And then we can get rid of create context. That's what the environment does already. And then what we still need is the run in context environment.get VM context. And then we run our test framework. Perfect, and now it's a bit slow. It takes 2 seconds to run our test because of the set timeout, but this node environment that Jest provides, it has set timeout and everything else. So let me just change this to like maybe 200 milliseconds so we're not slowed down while we keep writing tests. So one of the things is, let's add a file. Banana.js file that says that it exports good, so it means that bananas are good. So we have our described test here, and let's add a require statement. Right, and then we want it to say, oh wow, that was an auto import somehow. I don't know how that happened. It tastes good. We expect the banana to be good. All right, this is like it's a good moment to recognize that I don't like silly names for variables in my tests, so I usually use fruits or vegetables, and it also makes it good because you have melons, which are not a fruit, they're a vegetable, and then tomatoes, which are a fruit and not a vegetable, and it makes it fun to write tests around that. So anyway, I was writing code. I have a hard time writing code and also talking about it at the same time, as you might have noticed. But the point that I'm trying to make here is that most of the tests are not isolated and just running arbitrary code to test it. They're requiring other modules, they're importing other modules. So I added a small module banana, and like my idea is that in this test, we want to require that module and then, run some code and like verify that it's correct. So now if we run this, it'll tell us requires not defined. So unfortunately, the node environment doesn't bring that because it requires a lot more stuff to bring in a full require implementation. But I would really like to figure out how we can get a require implementation into our system. So we'll probably need the path module again. I'll give it away. We'll need the dir name and the join functions from the path module. And then we'll create our custom require implementation. And usually it passes in like a module name or a file name. I'll just call it file name for now. And then we'll need to read our code. The interesting thing is like we need to do it synchronously here because require is synchronous. And then we have we'll do it relative from our test file. And then concatenate to our file name and read it as UTF-8. Okay, so we have the code for this file that we're requiring. And then we need to run it somehow. So maybe we can run it in context. Get VM context. And then usually that might work. Let's try it. Oh, requires not defined. So we also need to pass it here. Okay, so we need to pass it as like a variable into our environment. Then we run it. that this module is not defined. Okay, that's interesting. So if we look at our module here, it says module that exports is good. Okay, so I just wrote some code. So whenever you call require, it will read the code of that module that we're requiring, and then we just run it in the context. That is not good enough. The thing is, the way modules work is that, you know, it works well for a test file because it doesn't import or it doesn't export anything. But the way a require implementation works is it provides this module object, and then it hands back whatever is exported from that module object, right? So we have something like a module with exports on it, and then we return module.exports. So now the question is, how do we fill in that exports? Let's see what happens now if we run this. It still says module is not defined. So maybe we could inject the module here with the environment, but then that's the same for the environment. So for each of the files that are run in each environment, we have the same module object. That doesn't work. One of the things that we can do is something like this. Let me step this out again. You know, we're running this code here, but it means we can actually amend this code. We can like just do whatever we want. So for example, let me add something. So we can do const module equals exports, and then add a new line just because that makes things easier. And then the cool thing is that the VM running context will actually return the last value from like the code. So if we just put an empty statement module that exports here, it should return it. So we could maybe return this and then see if it works. Oh my god, it actually works. So it expects a banana to be good. If we say bad, then it will tell us, oh, it actually received good, but it is actually bad. Perfect, so this works. The problem with this approach is that it can kind of leak out because we're just running this. So whenever we run the next module, it will tell us module is already defined. We can actually try this. Let's add a new file. Oops. Apple.js. And apple is not just good, it's delicious. And then in our describe test, we'll do and then we'll do expect apple to be delicious. Well, actually, let's do apple to be good, because then we have a failing test here. I'll also make this one pass so that we don't get that one. It tastes good too. Okay, so this test will intentionally fail. For some reason I have a VS Code auto require here that I don't want. Okay, so this one is going to fail, this one is going to pass. So we have two require calls. Let's see what happens. Oh, module has already been declared. Okay, so this is the point I was trying to make here. We are running this in the context, const module equals this. And then the second time we require, we run the same thing, const module equals exports. But the problem is that this was already defined previously when we called require. So we need to find a way to actually isolate this. So the way we can usually isolate things from each other is by, you know, variable names from each other is by creating a block, a code block. But then it gets harder to return this value. And a better way is usually using functions. So if we get rid of all of this and we somehow inject a module, then maybe we can make this work. So I already was talking about how when we had module exports here at the end, it was like returning that here. So maybe we could just run this function and then get this module factory. And then we run this module factory with this module that we create in the parent context and then return module.exports. Let me just walk you through this one more time. We're calling VM running context and we're defining a function in the context. So we're not actually running the code, we're just defining a function. And the way VM running context works is it will return whatever this is evaluating to. So it returns this function. We assign it to module factory, and then here is where we actually call it with this module object we're creating up here, which gets then passed into this, and then the code of our module actually runs. This code, it will call banana.js, it will set module.exports to good. So here it will say module.exports is good. And then that means it accesses this field on module, and then we can return it here. Let me try it. Function statements require a function name. No way. Ah, interesting. Okay. This is a function statement. Now it's a function expression. I have to add parentheses. Okay, perfect. It works. Our apple is expected to be good, but it is delicious. This is basically it. I'm going to try to clean this up a little bit. Here we're reading the code for our module, but we could use custom require for our test as well. So let me just get rid of this. And then we can do... Okay, I need to get the base name because so instead of code here, we'll do custom require base name of our test file, because here we're adding the name of the directory path, or the path to this test file without the name of the test file to the file name that we passed to custom require. So we can do custom require. We can get rid of this. It should work. Base name is not defined. Oh. I need to import base name. Oops. Perfect, it works. Let me run it. Okay, all of it is running. This is it. All right, we did it. So one of the things is that when we're building a test framework, we have, like, let's see how much code we have. Let me just count it. It's 43 lines on the worker and about 57 in our index file. You can find all of this code on GitHub. I'm publishing it there. So it's only about 100 lines of code, but we have everything that you can find in a modern test framework. We are finding files on the file system efficiently that will scale for really, really large repositories. We are running tests in parallel across worker processes. We're pulling in expect, jest-mock, jest-circus, and we're using the VM module and the jest node environment to isolate tests from each other. So this test framework will actually scale really well, and it's faster than most test frameworks out there, except for Jest. Well, actually, this is going to be a lot faster than Jest because it has way less features. You know, if you're building, a real test framework, then we need to actually add a lot more features. So one of them is the require function that we just built, like, only resolves modules relative to the test file. So there's like a bunch of change that we need to make. We need to actually make it per module. There's a bunch of stuff in Jest called Jest runtime, Jest resolve, or Jest transform to compile files, to resolve them properly, to provide a require implementation. But this is a lot of work, and you should now have all the knowledge required to piece together a testing framework. And if you've made it this far, then consider adding the following features to your test framework. One is printing the name of every describe and it, including the past test, the tests that passed. Print a summary of how many tests and assertions passed or failed and how long the tests took to run. Ensure that there's at least one file in a test using it, and fail the test if there aren't any assertions. Inject describe, it, expect, and mock using a fake module that can be loaded via require best. So you can change the custom require implementation to fake modules. Those are all like fairly simple extensions. A little bit harder would be transforming the test code using Babel or TypeScript ahead of the execution. Medium task is also adding a configuration file and command line flags to customize test runs, like changing the output colors, limiting the number of worker processes, or maybe an option called bail to exit as soon as one test fails. Another one could be adding a feature to record and compare snapshots, adding a watch mode that reruns tests when they change. You can use jest-haste-map and the watch option for it, and then there's a haste-map change event. That's very hard actually, but super fun. Making use of jest runtime and jest resolve to add a require implementation, or thinking about what it would take to collect code coverage. V8 has a mode to add code coverage, and then how can we transform our test code to keep track of which lines of code were run. With exactly 100 lines of code, we build a powerful test framework that's similar to Jest. And as I said, you can find the full implementation on GitHub. And while we added a lot of features that are commonly found in test frameworks, there's a lot of work needed to turn it into a viable test framework. So apart from the things that I gave as challenges, there's one that's sequencing tests to optimize the performance of the test run, compiling JavaScript or TypeScript files, collecting code coverage, interactive watch mode, snapshot testing, running multiple projects in a single test run, live reporting, printing a test summary, and a lot more. And as you've seen, Jest is not just a testing framework, it's also a framework for building test frameworks through all of its 50 packages. I really enjoyed going through this and live coding. That's like quite an exciting thing to do. In the next video, we'll be building a JavaScript bundler, which is going to build on all of the knowledge that we just gained. So, even if you're not looking to build a test framework, if you learned all of this, you'll be able to leverage some of these packages to build a JavaScript bundler. Thank you so much for joining me today and listening. This was just awesome, and I hope that you had a good time too.